So hello everyone, thank you and welcome to today's webinar. I am Nitzan, I'm the marketing manager here at Authz. Before we get started, I would like to mention that this session is being recorded and we will send you the link by email, and also it will be available on Authz and Giant Swarm website. Also, we would love to hear from you today, so if you have any question to one of our speakers, feel free to submit your question in the Q&A tab you can find here below. We will address as many questions as possible at the end of the webinar. With that, I would like to dive right into today's webinar, using Istio to secure and monitor your services. Our speakers today are Gadi Naol, the CTO and co-founder at Authz, and Fernando Ripoll, solution engineer at Giant Swarm. We will start with Gadi. So Gadi, thank you for joining me today. Your mic.
Thank you, Nitzan. Hello, everyone. I'm very pleased to have all of you on this webinar and super excited to do this with our friends at Giant Swarm. So on today's agenda, we are going to kind of delve into what are the motivations to actually use service mesh, bearing in mind that we are trying to kind of use the right tool for the right task. We are going to look into what's in the security stack of Istio and how we can extend Istio security. And then Fernando is basically going to cover the monitoring aspects of Istio, what are the monitoring concepts that are available, the monitoring stack of Istio itself, and how we can extend the monitoring stack of Istio. So without further ado, when we try to think about why do we want to use service mesh, for those of you who are already using Kubernetes today, one of the main challenges when it comes to dealing with microservices and highly distributed environments is that it is quite difficult to operate those environments. It is extremely difficult to troubleshoot and debug those environments when it comes to using use cases or modern use cases of intelligent routing between the different services and actually providing capabilities around high availability across regions or locality-based routing. This is something that it's relatively not easy to implement using existing constructs. And naturally, when it comes to the operational side of things, service mesh and Istio specifically brings in a lot of extension to our application code when it comes to monitoring and the observability side of things. From a security standpoint, the fact that we have a lot of moving parts within the service mesh, just like in Kubernetes, and the fact that we have services that interact with other services, it becomes a relatively hard challenge to kind of address in a meaningful and in an effective way. So if we try to kind of define what service mesh is, it is basically a uniform application runtime that extends our existing application code and introduced deep observability and controls into the environment itself. And then again, bearing in mind that we always want to keep using the right tools for the right tasks. So what's really inside kind of this magic box of Istio and the service mesh? So it's really being divided into three main components. Some of them Fernando will cover later on in this webinar, but from kind of a high-level overview, it's about connecting, it's about managing, and it's about securing services that are running and interacting with each other and with third-party services that actually lives outside the mesh. So one simple example around that is if we have payment processing or very kind of common integration of cloud-native applications today with Slack and log forwarding systems, these are types of external services. And when it comes to connecting the services, it boils down to the ability to do layer 7 path-based routing based on headers and based on the source of the client, whether they are using, for example, a mobile device which is iPhone-based or Android-based and that sort of use cases. It's about the ability to deploy or gradually roll out features in kind of an A/B testing mode and canary upgrades when it comes to managing and operating the service fleet, it comes to the ability to kind of have monitoring injected into the services and the ability to trace kind of application transactions that spans different services across the mesh. And from a security standpoint, it brings in three kind of core components that when it comes to implementing them by kind of application developers, it boils down to the ability first off to inject mutual TLS, which is basically an authorization layer between the transport of two services that interact with each other. Implementing that in code is something that is relatively hard. By introducing that layer, by introducing the certificate and the identity to the services. So Istio, in that sense, lifts a lot of the burden around that. And then when it comes to introducing API level access control, so think about it as RBAC, just like in Kubernetes, that you can enhance using configuration. Your code is something that is extremely kind of powerful around what Istio brings into the picture. When we try to kind of capture the main security components within Istio, so we have the control plane, which is basically responsible for the routing, which is the pilot component, Citadel, which is basically around the ability to do the identity provisioning to the running services. And then Mixer is responsible for a lot of kind of functionalities around the policy authorization, the quota management, and it's pretty much an extendable control plane. And kind of inside the mesh, we have the edge, which is basically covered by the egress proxy and the ingress proxy. Think about them as kind of your perimeter or edge components that kind of mandates what can exit the mesh and what can enter the mesh. And within the mesh, we have the sidecars, which are basically allow us to implement the MTLS between the services, the routing, the telemetry, and basically provides the kind of backbone for extending the platform itself. When we try to think about the what Google are actually doing around service mesh, so within Google, and there's a link in this slide, which we will send after the webinar, around what is the Istio or service mesh-like implementation in the internal system of Google. It's basically called Application Transport Layer Security. And it pretty much captures some of the extensions that exist within the Google infrastructure, but doesn't exist in Istio itself. It's a very interesting paper about the spirit and notion around service mesh origins. When it comes to the data plane of the service mesh, Envoy is kind of the backbone, which on top of the entire control plane of Istio is basically programming. So think about it as kind of the extension to your application. It pretty much, once injected, sits in front of your application. And once it is running in front of your application, it is enable you to kind of have logging, quota, authorizing the access between different policies, injecting TLS between the running policy, the running services. And around that, Envoy pretty much has a pretty extendable APIs, originally coming from Lyft as a project that emerged from internal needs that the folks at Lyft kind of had to deal with from an operational standpoint. And Istio control plane basically programs the Envoy data plane as kind of the backbone of the entire service mesh. It's a highly performant proxy server implemented using C++ and has a lot of extendable kind of subsystems that Istio leverage, and we will kind of see some of those in this webinar. Recently, Istio kind of shifted into the 1.1 version. It represents kind of a progress around the ability to adopt Istio as a platform. Some changes has been made to the APIs, and you can see on the resources that are being deployed into Istio that the resources are still at their alpha version, and we do see some progress around that. Istio 1.1 pretty much brings in some sugarcoating around the ability to isolate services using a new resource introduced in this kind of version called Sidecar. I will be going deeper into that in the next slide. The ability to run a service mesh across multiple clusters. We'll see a specific use case around PCI compliance in an Istio-oriented environment. Kind of streamline the installation of Istio with Helm. One of the main kind of features that resonate with the power of the service mesh is the ability to have locality-based load balancing, which pretty much kind of tells around the ability to do load balancing based on regions, based on the availability, based on the proximity of the user to a certain part of your service mesh. It's a very powerful feature. It pretty much brings in kind of global scale features to operate service mesh for those use cases that are relevant to that. Anything around the identity provision is now being made by SDS, which is the secrets discovery service, which is part of the Envoy APIs. Vault, I'm pretty much sure that many of the folks here on the webinar are using Vault already. Pretty much Vault integration as kind of the CA for Istio as a platform. Egress policy is now on by default, which pretty much says around who can exit the service mesh itself. Policy checks are something that is kind of the service mesh is powered by that, but it's off by default. And one of the kind of main concerns around the fact that there is kind of a multiple of workloads running inside service mesh because of the sidecar is the fact that performance, scalability, and stability was improved heavily on both on the sidecar side, but also on the control plane side from a memory consumption perspective, from a CPU consumption perspective, and on the sidecar itself, related around the network performance and latencies. When it comes to this new resource called Sidecar, we can see that the Sidecar is basically the configuration that pretty much allow us to kind of understand how we program the Sidecar to behave as a front end to the existing application code that is running. Because it's kind of a network construct, you can see that the APIs has evolved from V1 Alpha 1 to V1 Alpha 3 in this release. It pretty much says on which workloads this Sidecar resource should be applied. It can be applied on a namespace-wide kind of notion. It also says that on the ingress, the Sidecar will be fronted by port 9080, and the backend of this Sidecar will be port 8080. So essentially, to the outside of the world, this service will be exposed on port 9080. And on the egress path, we can see that the application can access an externally hosted MySQL server, which is being hosted on mysql.foo.com, which we see down here. And it pretty much enables us using kind of a direct mapping between the Sidecar and the backing application code to create this kind of proxy layering in a pretty simple way. It's some of the performance improvements that we managed to get within Istio 1.1 was due to the fact that we don't need to route all the traffic through the kernel and doing the IP tables redirection and the transparent redirection back to the application. We simply help, in kind of quotes, Istio to understand which exact ports need to be exposed to the outside world. And based on that, we managed to achieve a significant performance improvements by not doing the traffic modification on the fly. Naturally, this is something that creates some sort of inbound and outbound isolation. But one thing too important, that this isolation pretty much represents the happy path, meaning that if everything works as expected, you can pretty much create boundaries around domain names, which in some ways can be viewed as a network policy. It is simply implemented by kind of having routing rules. But on the other hand, think about what happens if there is something that kind of tries to interact with the outside world, not using those specific ports within this service. In that case, it is pretty much wide open to the outside world when there is no redirection implemented at the IP tables label. And you can see that the capture mode is pretty much mandated by the capture mode attribute on this resource. So it's pretty much new to 1.1, brings in a lot of enhancements, and it's really good to see kind of how Istio really matures as far as the resources goes. When it comes to service-to-service authorization, and some of you that do know Kubernetes, Kubernetes itself has kind of an RBAC implementation of which services can interact with the API server of Kubernetes itself. So Istio RBAC pretty much enables you the same superpowers, even relatively slightly more powerful than what Kubernetes actually offers internally as kind of a construct of the system itself. And the ability to implement using configuration or enhance your existing application code using configuration to pretty much describe which other services can interact with your service and using which permissions, whether this is read access or write access. And you can see that the resources are pretty much, in this example, captures the spirit of we want to ground to authenticated user, which is pretty much mandated by this property that we see here, that the source principal is equal to anything pretty much after authentication, which is how the internal machinery of Istio works. And then based on the headers, we can specify the condition of who or what part of the service we interact. And based on the HTTP verb, we can specify whether this is a read or write access. So if we were, for example, to write here that the methods are also post, then it will pretty much say that this is this rules basically enables us to also write into the service that we pretty much capture in this example. Kind of ahead of the curve in a lot of ways. Istio 1.2, it's not released yet, so hold your horses, but we did want to kind of give you a sense of what's coming ahead of the curve. So the authorization layer is going through a very deep revision based on the lessons learned from the previous revision of the APIs and kind of to address some more advanced use cases. So the second revision of those APIs pretty much enables or extend the existing one by enabling of deny into the policy. So up to this point, with the currently released version of Istio, all the RBAC are pretty much whitelisted and additive one to another, meaning that we can only add kind of permissions or access permissions to services, but we couldn't actually deny specifically access to certain services. So it's a very strong enhancement that comes into the mix. And the fact that we can introduce kind of different level of granularities for applying those policies enables us to kind of relieve the burden of managing, a large amount of YAMLs that captures the policy. At the end of the day, once you have a lot of moving parts that runs inside the mesh, this is something that creates an operational burden, and getting on the knobs and tweaks on the policies is something that becomes extremely difficult over time. So a lot to expect in Istio 1.2 around the authorization side of things. Bear in mind that that this is not something that is presently released. So let's take kind of a specific example around the impact of using Istio in the context of applications that do require the PCI DSS Compliance. PCI stands for the Cardholder Information Services. It's a compliance that pretty much mandates that cardholder sensitive data will be reside physically on an isolated location. So when it comes to that, one way of approaching this problem, based on the fact that Istio as a platform pretty much abstracts the underlying network and enables us to see the world, or at least help applications capture the world as kind of an application to application interactions without worrying about the underlying network and the underlying infrastructure. So Istio by itself make strong assumptions on what the underlying network looks like. And here specifically what we did is we grouped the entire workloads that deal with PCI cardholder information in one cluster that runs the workloads or the services that interact within the PCI sensitive data. And then anything that is related to the application itself is running on another cluster. So we were able to create the physical isolation between the two environments or the two workload types, which pretty much is in line with the compliance spec itself. But then again, we still benefit from the fact that we can leverage Istio as kind of the service backbone or the kind of the engine that powers all this application as a whole. Of course, once you move into Istio, it makes a lot of sense to run things in a highly distributed manner, and oftentimes you will end up running multiple Kubernetes clusters, or even can involve the usage of VMs as part of the mesh. It's pretty much tuned and geared to that as well. So we've talked a lot about what Istio and Service Mesh does have from kind of a platform perspective, but it is important to note that Istio makes assumptions on the underlying infrastructure. So it really means that anything that doesn't live on the happy path, or if you have a kind of a mixed environment where some services run inside the mesh and some of them are running outside the mesh, and we always have services that are pretty much running outside the mesh. Take, for example, system workloads, elements that takes care of doing the log shipping. So oftentimes it doesn't make sense to route all the traffic through the entire data plane of the mesh itself. So when it comes to that, it is really important to make sure that the underlying infrastructure that runs your service mesh is secured as much as you take care of your service mesh. So oftentimes, I do see kind of deployments where the base assumption is Istio takes care of your entire security needs. It's by design. It's not something that is correct to kind of go to this approach. It is really easy to bypass, for example, the sidecar hardening if you have containers that are running as root, for example. So when it comes to that, think about it as something that needs to be taken care of. What's happening inside the mesh using the RBAC policies and the sidecar resource and all those kind of good constructs that Istio gives. But on the other hand, don't leave out the underlying infrastructure. You need to have kind of a game plan of what's happening if something pretty much leaves your mesh. DNS tunneling is kind of the backbone for service discovery of the underlying network is another good example. And of course, anything that happens or smells like anomalous behavior is something that you do want to have systems that do that sensing and perform kind of deeper controls of what exactly is happening inside the mesh. One example, a pretty recent one around the fact that Sidecar itself, because this is a component that runs across your entire service mesh. There was a recent vulnerability on Envoy itself, so pretty much vulnerability on the data plane. That pretty much based on the traffic, you could end up manipulating the Envoy itself. So without getting into the details of that, naturally the fact that we are introducing a component, a sidecar into this infrastructure, it is something that has implications from operation and cost perspective. It does have implications from a security standpoint, and the blast radius naturally is kind of correlating with that. So touching briefly about kind of detecting anomalies and as a segue to Fernando's part of this webinar, oftentimes when we monitor systems, and we monitor them also from a security standpoint, there is a very good SRE book by Google. You have the link on this slide. which pretty much captures the fact that if you want to start monitoring your systems, there are 4 golden signals to track. Latencies, which pretty much, talks about how responsive my services are. Think about it from a security standpoint. If you are experiencing a DDoS attack or some sort of a volumetric attack on your systems, one of the side effects that we see in those attacks is the fact that our service becomes less responsive and the latencies have some sort of a negative drift within them. Other aspects are around traffic, how much demand we can place on the system. So it pretty much boils down to requests per second. Errors is a very important signal to track. So if we have a negative trend of our error rate, this is something that we do want to kind of flag our DevOps, but oftentimes can be something that needs to flag or alert the security teams. And saturation is pretty much around how full our systems are. So think about it is how busy our CPUs in a consistent manner, how busy our IO system from a data access perspective. And for every kind of ops signal that is in the kind of system, we can immediately see that securities also can be something that creates side effects on those signals. So with that in mind, I would hand over this webinar to my friend Fernando on the Giant Swarm side. So Fernando, please take it away. I do encourage the folks on the webinar to send us some questions. We would be happy to address them. Hope that they are not too kind of difficult for us to address online, but we will try to do our best. So Fernando.
Hi, Gadi. Thanks for the introduction. So now let's move to the second part of the talk. And this is more focused on the monitoring side of Istio. And as Gadi has mentioned before, there is a couple of components that I would like to make a quick short recap what they do, because they are really important for the monitoring part. The first is the mixer, which is the main one of the main components on the control plane, and it takes care of gather the telemetry data from the proxies forward to the backends that wants to hear this kind of data. And the mixer has been built upon two principles. The first one is the backend abstraction. So the community wanted to not couple the Istio to any specific DSL domain specific language provider. And the second is the intermediation, which is doing giving the ability to the operators to define fine-grained control over the interactions between the mesh and the backends. So let's move and define what is really a backend. A backend is just an infrastructure service that give us or extend the logic out of the mesh. And here we see some examples. We have a stack driver, we have Datadog, Prometheus, but it's not just only monitoring tools. As you see, there is also Jagger, which is a tracing tool, or OPA agent, which helps with the policy enforcement. And then let's define what is an attribute, because it's one important piece here, and it's the smallest information bit, the smallest information block in Istio, which flows between the proxies and the mixer. And it contains data about the environment, the request, and all around. And it usually originates from the proxy, but the mixer or your workloads itself, as we will see later, can also add attributes to the mesh. So in this example, I show you the source IP. That is one attribute which obviously gives you information about the source workload IP address. And here the sample is in Kubernetes, so it will be the pod IP from the origin of the request. And the second one is the request path, which is the HTTP URL path that is extracted from the HTTP packet. So this is the two examples. As you can see, there are many others. Then we have the adapter, which is the glue that maps the attributes coming from the mixer to the specific backends that require that. This is the way that mixer abstracts from the different protocols, APIs that the backend offers. So all the logic is contained in this adapter, and the adapter decide how to translate this to the specific DSL, the specific domain that the backend speak. Now let's move to the instance, and the instance is a common entity that has been defined by the community. Here we see the example of a metric. So instead of have multiple entities for this created by its backend or its provider, there is some agreements, and for example, all the providers that want to listen for metrics or want to script metrics will specify, have this interface, which in the spec you see there is some properties like value, dimensions, or the type of monitoring. And using the dimensions, how we map the attributes, the source workload name and the destination label version to a specific values, specific properties. Then we have the handler, which is the configuration of the backend itself. So as every backend has a different way to be configured, we need to map the instance that we have defined before to a specific backend. So this is the configuration that we add in the handler. And here we are giving the example of Prometheus, and we list the metrics in the spec that we will scrape from the mixer, from the adapter, to be more precise. Then we define here the name of the metric that will be able to be queried by the interface lately, the instance name that we have defined before, what kind of metric is it. So in Prometheus, we know that there is some types like gauge, buckets, or counters. So here is going to be a counter. And then we define which labels we will take. So that's the parsing from the dimensions to the domain of Prometheus, which is called labels instead of dimensions. So we select the source and the version. And then we need something to tie the two before concept together. And this is the rule. The rule, as we see, has in the spec a proper object that is called actions, and in the actions we see the handler, which is the handler that we had just defined before, and which instance this handler will be configured with. And also we can define some conditions. Here we are matching to only forward or only provide this for the services, or for the destination services equal to current services. So these are the main concepts I would like to touch. And now let's define, or let's show you what is the typical monitoring stack Istio offers. As I said before, there are different options. You are not tied to use Prometheus here or Grafana, as we will see later, but this is the most common stack that I'm seeing the community is using. So Prometheus is an open software project, and it has landed in the cloud native landscape some years ago, and is like the de facto monitoring tool nowadays in the cloud native world. It is a time series database, and it has a model pool mode, HTTP pool mode, sorry. So it scrapes from different targets, and it comes with an alert manager that is able to define alerts and forward then when they are triggered to different incident management tools like PagerDuty or Opsgenie, whatever you want. And the next tool is Grafana, which probably you already know, but it is a tool to visualize the data from different data sources. It comes with plenty of different widgets, and it has a powerful filtering system, provide you also with authentication and an alerting system built inside. But here it's good to say with Istio you have like three predefined dashboards that are automatically added to Grafana when you enable Grafana in the Istio deployment installation. And the first one is just an overview of the mesh. So you can see in a quick shot how the mesh is behaving and the list of services that you have and if they are red or green. You can click in one of those services and you will be redirected to this service dashboard, the one that we are seeing now on the screen. Then here we can see that the connections that are coming from and they're going from the services. So we see the traffic flowing. And then we will have also another dashboard, which is the workload dashboard. And it is more focused in the workload itself. So as we will also explain a bit further later, but there is some monitoring approach called a black box monitoring, and it allows the operator to, without know anything about the app, be able to see if something is happening or not. And in this dashboard, you will see there is some metrics added by default. And then we have Kiali, which has become the de facto UI of Istio. It is a powerful tool. It comes with some screens to configure your services and to see if there is any problem with configuration. They have a validation system which validates against a schema, so you can see if you have something wrong in your definitions. Also, it has a service dependency graph, as you are seeing now in the screen, with what is the chain of your services and how the request flow over the mesh. And you can click on these arrows and see some monitoring, some metrics like errors or the TTP request, things like that, which is great. And also, it has a link to the train scene. So you can also jump from Kiali to Jaeger quickly. Now I would like to talk a bit about the Dataplane monitoring, which is, we know that Istio will allow you to monitor our own workloads, but at the same time, it's really important to verify that the proxies in this case are behaving as expected. First, Istio is a great tool. It has plenty of features, but it comes with a price. And this is the latency penalty that you suffer for every hop in the service chain. And this is something good to track and to have some monitoring eyes there. There are some things that, like in the roadmap, that could improve this latency problem, but like BPF or the CNA plugin that the community is preparing. But this is something that always will be good to know what is the impact of the proxy. Then we have some problem with the performance when the secrets are rolled out. So as Gadi has defined before, every service has an identity. This identity is proven with a credential. This credential has to be rotated over time. And before there was some hiccups when this was rotated, so you could see that on Grafana. And now with the feature that also has explained Gadi, the secret discovery service, this will be fixed, and you will not see anymore this problem. So it is good to change to it. And then also a good thing is to monitor the resource consumption of the proxy. The proxy used to catch the policies that you define in the cluster, and also buffer the telemetry data and send that from time to time to the mixer. So it's good to see that this is under control and there is no memory or CPU problems with the proxy. And this is something also that is being working in the community, and the last version have some improvements. Sidecar resource, as Kadi mentioned, is a good improvement. And about the application itself, with the Grafana dashboard I mentioned before, you can have this kind of black box monitoring approach that you see the rate, the errors, and the duration of your services without touching any line of code. So you see if there is some request per second spike, or if suddenly there are errors returning from your API or from your services. So that's a good a tool to start with the monitoring of your applications. And then I would like also to mention that the control plane monitoring is quite important, and especially if you are running in production, you will need to see that the pilot, for example, is behaving. Pilot, there has been some troubles in the past in terms of memory consumption. This has been polished, and new versions has been better on that. But it's good to have an eye on it. Obviously, the ingress egress gateways are quite important. Because they route the traffic in and out the mesh. So we need to see that they are in a good shape and there is nothing happening on that. These components are in the Kubernetes deployment scale automatically, so they have this horizontal point auto scaling on place. But anyway, it's good to have an overview of how they are moving. The policy mixer, let's explain. In the last Istio releases, there has been a change, and now the mixer has been split in two. It's the same binary, but one is started as policy and the other for the telemetry part. So they are not mixed into like mixer responsibilities on that. And the policy mixer is a quite important component because it is the one that enforce the policies defined by you. So the pilot has to check that, the data proxies has to check that the policies are up to date. When this component has troubles, it can cascade and provoke also problems into the proxies. So that will be a good component to take care of it. And then the upgrade process. I bring this to the table because the Istio project is quite young, and as you see in some slides before, Gadi mentioned that from one version to the other, there are changes on the APIs, there are changes on the components, and sometimes the upgrade from one version to the other are hard. And even the community are providing good documents how to make this transition. It's good to really take a look on that and monitor all this upgrade process closely, so there is no impact really in the traffic of the mesh. And now let's talk a bit about the extending the monitoring. So there is different options that you can use to extend the monitoring. One is you can define your own adapters. So imagine that you have your own monitoring tool, you have your own process that need to integrate with Istio. You can always develop your own adapter, and there is a good document guidelines provided by Istio that you can follow and explains all the parts of an adapter, which interfaces you have to implement, and then you can create. A good hint here is before Mixer came with the adapters built in the same binary. This has been changed. Now it's out of the tree, they call it. So you can run adapter out the Mixer component, and they can be integrated with the component. So the other way that we have, and it's the one that I showed you when I was explaining the rules and the handlers and the metrics, is you can define your metrics. You can take the attributes that you are interested on and grab that on the metric and configure your handler and your adapter to provide this information to the monitoring tool that you are using. But also you can obviously create your own monitoring, your own metrics, like the other kind of the counterpart of the black box monitoring will be the wet box monitoring. So is the metrics or is the collectors that take information from your own application and expose this information to the outside, and this can be obviously encoding your own application. And for example, in Prometheus, you can create your own exporter or your own collectors, and then let Prometheus scrape those. So you get this information in the same monitoring tool. But also there is a really no famous or no concept in Istio, and it's this HTTP API spec, which allow you to define how your APIs are structured. So this is kind of Swagger of this open API model, and then you can define here in the spec which attributes you can generate from this request to the API. So here we are generating attributes for the operation find pets with the method get. And this, when you submit this to the Istio, when you apply this configuration to Istio, it will generate this attribute from the proxy that match with this spec. And then you can inject those to the adapter and the monitoring tool, and then you can have this information in the tool. So yeah, now 3 takeaways I would like to share with you. First of all, understand the concept. As you see, there is kind of new lingo here in Istio and new concept, and there are some words that has been used in different domains, so you have to get used to it. It is quite powerful and flexible when you control. So yeah, read the docs, play with it, and have a really good understanding of these concepts. Then track your mesh components. As I said before, it's quite important that the control plane and the proxies are under control, and you see what is happening with them. And then as a third takeaway is standard observability. So yeah, you have different ways to get more attributes, to get more metrics into your monitoring tool.
And on the security side, naturally, it pretty much correlates on how we monitor things. So it's about have deep understanding of what the mesh network policy offer and what exactly it covers, and do take a note of what it doesn't cover, and kind of separate between the assumption that Istio makes on the underlying infrastructure. Track your mesh components from a security standpoint. What are the exact interactions? Search for any anomalies, and then any observability that is being deployed into the environment. Make sure that you are also doing that from a security standpoint. So take the simplest example. How do you know you have crypto mining inside your service mesh? So with that in mind, we will switch over to some Q&A. So we have a question from, and I hope I'm spelling this correctly, from Nick Hill. Question is, What are the benefits that Istio brings onto the table in respect to RBAC and ABAC as far as service-to-service communications? So addressing that part is mainly around the fact that Kubernetes by itself has RBAC features for defining access to Kubernetes as an API server itself. Istio, on the other hand, gives you the ability to define RBAC roles and rules for your existing application code. So think about it as, and we've touched it briefly in this webinar, that Istio enables you to use configuration to enhance your existing application code with literally role-based access control rules that are very granular and provide API access level controls. From the same guy, the question extends and goes beyond, does RBAC and admission controllers are not enough for Kubernetes to secure the services? And the straight answer is that in the context of Istio, Kubernetes RBAC doesn't cover the Istio services themselves from an RBAC control standpoint, but you can use the admission controllers to perform, let's call it service mesh hygiene, in the sense that you can test whether services, for example, are deployed with Sidecar configuration applied to them, just like you would do, for example, with Kubernetes and network policies, and whether services are deployed with RBAC rules defined to them. So this is where admission controllers can come very handy as far as the underlying infrastructure. And second part from Fernando.
Yes, can you hear me? Yeah, right. Yeah, the second part, the question is, from monitoring point of view, the metric server give us aggregated custom metrics. Prometheus is quite advanced and sufficient for app-related metrics. I don't know if this is a question, but yeah, the metric server, if you refer to the Kubernetes metric server, yeah, it provides you with some basic metrics from the Kubernetes cluster, but you still need to have an adapter to get it into the Prometheus. And to be sure, sorry, there's some moving in the screen. And yeah, and I'm not completely sure if you can integrate metric server with the Istio. Probably you can, but I'm not really deep on that. And yeah, Prometheus is like, yeah, I will say that it's the most common tool use it here. And indeed, all the installations, all the default, all modes of installation that provide you Istio comes with Prometheus enabled, and that's because Kiali is using it, or other components are using it too. So this is like a quite important piece.
Okay, so if we have no more questions, I'd like to thank everyone for joining us today. Thank you, Fernando. Thank you, Gadi. For the next
There's a question.
Yeah. Fabio, we will take it later. We will answer you one-on-one on this question for the hands-on. So thank you everyone for joining us today. If you are attending KubeCon Barcelona, make sure to stop at Giant Swarm booth or at Authz booth to say hi. And that's it. Thank you again and have a good day.
Thank you everyone. Bye.
Thank you everyone.